Well, hey everyone, it's been a while since I've posted one of these videos, but with so many people being sick, I thought that it would probably be a good idea to start posting these on the blog again, so that if you are absent, you have a chance to kind of catch up on what we did in class. And if you need extra help, then it's there as well. So we've talked about it last Thursday and today Monday, on how to identify the different parts of an expression. And so just as a quick review, algebraic expressions typically have four parts. So we have variables, and variables are always letters that represent a number or a series of numbers. And remember, we're going to be working with x, y, z, and n for the most part, sometimes k and other letters, but keep in mind that as you get into higher levels of math, you might see Greek letters as variables as well. Terms are the things that are separated by an operation sign, and if there's not an operation sign, maybe it's just 4x, then that's the only term that you have. Coefficients, if you were in class today, think a hot chocolate packet with water. They go together. And so coefficients, that's the number that is in front of a variable, and if it's just a variable, then the coefficient is always 1. And then constants, those are the numbers that stand alone. And remember, we talked about root words today, and constant, we have STA, and that is standing still or standing alone. Okay, let's get started. So if we have the expression 3x plus 15, we need to identify all four parts. We need to identify the terms, we need to identify the variables, we need to identify the constant, and we also need to identify the coefficient. So the terms are separated by an operation sign, and here my operation sign is addition. So I look at what it's separating, and I see that it's separating two things. It's separating 3x, and it's also separating 15. So those are my two terms, 3x and 15. Now my variable is always a letter, and I see that I only have one variable, and it just happens to be x. So x is my variable here. Now for my constant, actually let's go to coefficient since we just did variable. So my variable is x, and as I look up here, I see, okay, what number is paired with x? What digit is paired with x? And that is 3, so that's my coefficient. It tells me that I have 3 x's actually. So my coefficient is 3, and my constant is what is standing alone. It's never attached to a variable, and so I see that 15 is just kind of chilling out here by itself, and so that's my constant. Okay, let's take a look at another example here. This time I have 10y plus 31, and again I want to identify my terms, my variables, my constants, and my coefficients. So let's take a look at my terms here. Again, my operation sign is addition. It's separating two things. It's separating 10y and it's separating 31. So those are my two terms. Notice I'm separating them by a comma here because it's 10y and 31. I could also write it 10y and 31. Either one works just fine. For my variable, I look for a letter. I see that y is the only variable I experience in this expression, so y is my variable. While I'm looking at my variable, I can identify my coefficient, the number that comes in front of the variable, and that is 10. So that's going to be my coefficient here. And my constant, the number that's standing alone and not attached to a variable, is 31. Now, what if I have an expression that's 6z? Let's take a look here. So again, I want to identify my terms, my variables, my constants, and my coefficients, and I'm just abbreviating here. So, first of all, terms. Now, I don't see technically an operation sign here. You know, I don't have plus 10 or plus 16, I just have 6z. So in this case, I actually only have one term, and that is 6z. Now my variable is of course z, which makes my coefficient 6 because it's attached to the variable. So now I have to think, okay, what's my constant here? So I have to think to myself, is there a number being added to 6z? There's not. So what number represents nothing? Well, 0. So my constant is 0. Okay, what about something like this? N minus 18. Let's get this set up. I'm looking for terms, variables, constants, and coefficients. Okay, operation sign happens to be subtraction. It's separating n and 18, so those are my two terms, n and 18. My variable, I see a letter, and it is the letter n. Now my coefficient, okay? So I have to think about some rules of multiplication. What number can be multiplied by any number, and that number stays the same? Well, 1. 1 times 10 is 10. 1 times 30 is 30. Well, 1 times n is still n, so my coefficient is 1. There's always an imaginary 1 in front of a variable if it's the variable alone. And my constant, I see, is 18. Okay, what if I have something like this? I have 6x plus 10y minus 10. I need to identify my terms, the variables, the constants, and the coefficients here. Okay, terms. I have two operation signs, and it's actually setting three things apart. I have 6x separated by 10y, and it's also separated from 10. These two things are doing the separating, the addition sign and the subtraction sign. So my terms then are going to be 6x is a term, 10y is a term, and 10 is a term. What about my variables? Letters. I have an x, and I also have a y, so they're both variables here. Okay, since I have two variables, that's going to mean I have two coefficients. I see in front of the x there's a 6, so that's one coefficient, and in front of the y there is a 10. Remember, this is the 10 I'm working with for my coefficient. Now this 10, there is no variable attached to it, so that means it's my constant, something that's standing alone or staying the same, and that's that 10. Alright, go ahead and try this one on your own. So pause the video, see if you can identify the term, the variable, the constant, and the coefficient, and then press play when you're ready to compare. Okay, so my terms are 4x, 2y, and 3. My variables are x and y. My coefficients are 4 and 2, and my constant is 3. Alright, helpful quote for the day: hard work beats talent when talent doesn't work hard. That comes from our good friend Kevin Durant, who is a player for the NBA team, the Oklahoma City Thunder. Anyway, good luck. If you have any extra questions, come talk to me. Hope you're all feeling better, those of you who are sick. Thanks. See ya.